In this video, we are going to describe how to do an outer product with two vectors. Now, in general, an outer product will appear as you have some kind of vector here. I'll just call it like u1, u2, all the way down to um. And the symbol for outer products that's sometimes used is a multiplication symbol inside of a circle. And we're going to go ahead and do like v1, v2, all the way up to vn. So we have a product done this way. And what happens when I do this product is I end up with u1, v1, and then I have like u1, v2, all the way up to u1vn, and then we have u2v1, u2v2, all the way up to u2vn. And we keep doing this for each entry in both of these matrices until we end up with umv1, or both of these vectors, umv2, all the way over to umvn. So this is what we call an m by n matrix. This is a 1 by n vector. And this is an m by 1 vector, where the first number in each one of these is the number of rows, and the second number in each one of these is the number of columns. So what ends up happening is that when we do an outer product with two vectors here, we actually end up with a matrix, not a scalar, like we see with an inner product. So let's take a look at a short example. So let's say that we have 1, 2, 3 as our first vector, and we're going to multiply this by -1, 0, 4 in our second one. So according to our rule here, we're going to take 1 and we're going to multiply by each one of these values. So we're going to have 1 times -1, 1 times 0, and then 1 times 4. And then we take 2 and we multiply by each one of these. So we have 2 times -1, 2 times 0, 2 times 4, and then we take 3 and multiply by each of these. We have 3 times -1, 3 times 0, and 3 times 4. And then we just do the arithmetic to simplify this down. -1, 0, 4, -2, 0, 8, -3, 0, 12. And this would be the outer product of these two vectors. Now, the advantage that this has in some cases is that it does simplify some notation down, but it also allows us to multiply vectors together that may not be of the same dimension. So let's go ahead and add on a new slide here. And let's take a look at another example where we have a vector. Again, let's just take 1, 2, and 3. Except this time, let's take just a vector of -1 and 4. So this is a 3 by 1, and this is a 1 by 2. So according to our calculations, we should end up with a 3 by 2 matrix, a rectangular array of numbers. So we're going to have 1 times -1, and then we're going to have 1 times 4, and then we're going to have 2 times negative 1, and 2 times 4, and then we have 3 times negative 1, and 3 times 4. So when we multiply that out, we end up with negative 1, 4, negative 2, 8, negative 3, 12. And this is our 3 rows by 2 columns matrix that results from this multiplication. And this is how you can perform an outer product multiplication when you have 2 vectors. So thank you for your time and attention.